Dear students, dear students, today we will start transformation. Oftenly we require to translate, I mean ki to shift the image, to rotate on some angle, to scale, I mean to enlarge or to subtract, and to shear, yeah, I mean to squint. Squint मतलब तिरछा. So the images are required to change their shape, their location, their presentation, way of presentation, which is denoted here, shearing, and their size too, that is scaling. So one by one we will discuss all this today. But prior to that, it is required that whenever a three-dimensional object is picturized on two-dimensional screen, it have some surfaces which falls behind the another one, and to make them more lively we use a third coordinate, and that third coordinate are required in all these activities like translation, rotation, scaling and shearing. So the third coordinate, which is known as homogeneous coordinates. So we may define that homogeneous coordinates are ubiquitous in computer graphics because they allow common vector operations such as translation, rotation, scaling and perspective projection to be represented as a matrix by which the vector is multiplied. So in this process we create a third coordinate. Now instead of being represented by a pair of coordinates like x and y, now each point is represented by a triple, that is x, y and w. At the same time we say that two sets of homogeneous coordinates like x, y, w and x dash, y dash, w dash represent the same point if and only if one is a multiple of the other. For example, let us take a point which represents 2, 3, 6, these are its coordinates, and for another which is represented as 4, 6, 12 are the same point represented by different coordinate triples. That is, each point has many different homogeneous coordinate representations by which we represent the points. Now we take a look one by one. So let us start with translation. A translation moves an object to a different position on the screen. We can translate a point in two-dimensional by adding translation coordinates ty and tx to the origin coordinate xy to get the new coordinate x dash y dash. In figure you are seeing that 2 points, one point whose coordinate is pxy and another whose coordinate is p dash x dash, whose coordinate the point p dash whose coordinates are x dash and y dash. So translation coordinates should be Tx and Ty. So, we can write the P dash point is equal to P plus T. Whatever the translation shifting occurred, that is denoted by T. In case of point P is translated and that is defined by T, whose coordinates are dx1 and dy1. So, the result is a net translation like T coordinates are dx1 plus dx2 comma dy1 plus dy2. So, to confirm P dax is equal to T dx1 dy1 into P1, the expression A, and expression B, that is P double dash is equal to T dx2 dy2 P dash. After substituting equation A into equation B, we get the final value, that is T dx2 dy2 multiplied by T dx1 dy2 whole multiplied by the original point P. So, in the term of matrix product, these may be presented as you are seeing that there are two matrices. One is representing the T dx 2 dy2 and another that is T dx1 dy2, and after multiplication you are getting the result on the screen. So, the net translation is described as T dx1 plus dx2 and dy1 plus dy2. So, this is the mathematical derivation in form of matrix which are used to do translation of an object in our graphics package. Now, we move to the rotation. In rotation, we rotate the object at particular angle theta from its origin. From figure, you were seeing that the point Pxy is located at angle phi from the horizontal x coordinate, which distance r from the origin. Let us suppose to rotate it at the angle theta. After rotating it, to a new location, we get a new point that is P x dash and y dash. So, P x y can be represented as x is equal to r cos phi and y is equal to r sin phi. So, using these expressions, we rotate an object in our graphics. So, these are the described, and next that is scaling. Scaling is a way by which we can change the size of our object. The size may be enlarged or may be reduced. So, let us assume that the original coordinate are x y, the scaling factor are sx, sy, and the produced coordinates are x dash, y dash. This can be mathematically represented as x dash is equal to x into sx and y dash is equal to y into sy. So, the scaling factor sx xy scales the object in x and y direction respectively The equation can also be represented in the matrix form as it is shown in the expression E and expression F. So, finally, we see that the P dash, I mean ki after scaling, equal to S, Sx and Sy multiplied by the original point, original shape P. If we provide values less than 1 to the scaling factor S, the size of object will reduced. If it is greater than 1, then the size of the object increases. So, with the use of these matrices, we do a scaling, I mean enlarging or subtracting the size of the object. Now, we take a look on shearing. Shearing is a method that slants कहने का मतलब कि तिरछा करता है. Slants the shape of an object is called the shear transformation. The shearing may be in both ways, that is X shear and Y shear. The X shear preserves the Y coordinate and changes are made to X coordinates only, which causes the vertical lines to tilt. कुछ तिरछा हो जाता है, tilt मतलब कि तिरछा होना, tilt right or left as below in the figure. You are seeing well in the figure on the screen. For this purpose, our transformation matrix is shown on the screen. And finally, we find that X dash, I mean ki the new position, the new appearance of the object is equal to X dash equal to X plus SHX multiplied by Y, whereas Y may be 0, Y may be sorry, I mean Y dash may be Y is original. So, the final one, which is composite transformation. We have seen a series of transformation like translation, transformation, scaling, shearing, but all these may be done in the form of composite transformation. So, composite transformation is done to gain efficiency by applying a simple composite transformation to a point rather than applying a series of transformations one after another, as we have just seen that to rotate a function, to rotate an object, we do something else using some matrix, whereas to transform from one location to another, we use another matrix. So, to do this, we do following steps. If we have an object which is at origin and that have to translate, rotate. So, with the help of composite transformation, we may do it. If we do not use composite translation, we will do it in 4 steps as shown in the figure. So, with the help of this transformation matrix, we can do a composite transformation. So, immediately I will show that how these translation are done using these concept, these mathematical approach in the form of computer programs. So, with the help of computer program, I am demonstrating all these effects on an object. So, let us move to the IDE. So, this is the program for composite transformation. Here we will do translation, then scaling, rotation and shearing. So, let us start. Here we will see that this is the way by which we can do shearing. So, we we draw a rectangle, and to draw a rectangle we have to input diagonal points coordinates. So, we input here 40, 20, 48, 28. So, the object is created on the origin. You all were seeing it on your screen. Now, we do one by one. So, let us do first translation. For translation, we required the translation factor. So, let us input 10 and 15. We will seeing on screen that the original image has been translated. I think you all were visible to it. So, this is the way by which we enter a translation factor upon which we have to translate the original image object. Second one is scaling. So, for scaling we have to use the factors. We use 5.5.6. So, you are seeing that the object has been reduced. Just we have described that to compact, to reduce, we put the scaling factor less than 1, and here you are seeing that I have inputted 0.5 and 0.6, and both these are less than 1. So, it has been compacted, I mean reduced in size. So, by this way the scaling is done. The third one, that is rotation. For rotation we have to input the rotation angle. Let us input something. I have entered 20 degree. So, you are seeing our object has been some diagonally appearing on the angle of 20 degree. So, by inputting the rotation angle, we rotate any object in our graphics packages. And shearing, just we have seen that how we may tilt, कहने का मतलब कि तिरछा कैसे कर सकते हैं. So, for shearing we have to enter the shearing value. So, let us enter 0.75. So, you are seeing the original image is appearing as a tilted image which is clearly visible on the screen. And now you all understood that how an object can be translated, I mean can be shifted from its original location, can be rotated, can be scaled, and can be sheared. So, okay, thank you.